So looking at the market, SMR research organizations already have been analyzing the market for SMR for some decades, I can say. Specifically high temperature reactors, that's what the picture is on. I see various products like iron manufacturing. Also the hydrogen is already there, but still with steam reforming process. You can make several chemical substances like ethylene and styrene and urea synthesis, but also the products that I told before, the desalination, district heating. So to give an overview of the products, and then also on the horizontal scale itself, it says the temperature that is needed. And the regular, high temperature reactors will go to 800, 900 degrees. That's a little bit where this vertical dotted line is. And so the very high temperatures will also cannot be served by the nuclear technologies. So what are the competing technologies? These are usually were and still are the fossil fuels. And so there's now a movement for climate change mitigation to get away of these fossil fuels, but for the moment they're still there, and that's what your competitive landscape is as well. And also within the renewable energy sector, there are efforts to engage with these markets through the so-called power to gas concept. So also, you have to look at your economies of scale. It is well known that nuclear power is capital intensive. So this applies to SMR as well. So to be competitive, SMR needs economy of numbers, multiple units produced in series. With the big nuclear plant, you could still afford to build it one by one, but the smaller ones, they need to get their competitiveness from somewhere. So you're looking at to produce these in multiples. So this is not only nuclear. This also is, for example, with airplanes. There's this event which we took from the New York Times about Airbus, that Airbus needs a minimum of 6 to 8 orders a year to keep production alive at the A380's final assembly plant. The newspaper article was if they're not keeping that, if they don't have any prospects to that these number of orders, these multiple planes can be produced, then the plant, the where it's fabricated, will have to shut down. There's also a nuclear example from the past. In January 2014, Westinghouse announced that it was suspending work on its small modular reactors in the light of inadequate prospects for multiple deployment. And there the company had said that it could not justify the economics of its SMR without government subsidies unless it could supply 30 to 50 of them. And so that's about the number that you have to think about. So if you look at competitiveness, with respect to whom it should be competitive. You could look at specific locations where it's, for instance, where it's very remote or on an island, it's very expensive to get the fossil fuel as an alternative there. And you could also think, to be competitive to traditional large-scale nuclear power. That has to do with this economy of numbers that it's needing. So you can produce identical units on multiple locations. So this is most probably the situation for non-electric products, but also multiple identical modules on a few locations. So maybe SMR development needs also that one for electricity only, or mainly electricity. And then it may need to be competitive against traditional large-scale nuclear power as well. So, and if you look at that, this diagram is very useful. If you look at the plant capacity, usual nuclear power plant, about 1200 megawatts. On the vertical axis is the cost per kilowatt hour. This is just qualitative. And if it's going up, if the plant capacity is reduced to about 300 megawatt electric, that's the kind of boundary for small modular reactors, then we need to make up for the loss of economy of scale by a number of topics. can assume a single unit and the same large reactor design concept. You can have multiple units. We can have learning, cost reductions for site and program learning because you have many additional units in series. You can have look at your construction schedule, reduced interest during construction because your construction time could be shorter, and the unit timing, that you have gradual capacity additions if to fit the demand. And also you can have cost reductions resulting from design concept characteristics. There are maybe certain simplifications possible when you reduce the power level. So that's the idea of competitiveness with respect to the large reactors. So summarizing, so we can find some economic principles that applying specifically to SMR. Economics are based on economics of numbers, modularity, standardization for commercial deployment. And this could allow the nuclear industry to be much more like an airplane or shipbuilding industry in terms of a deployment model. And the fleet approach would see SMR designs built in factories, promoting standardization and learning by doing through the building of subsequent identical units. Now I will discuss a number of challenges, which are also opportunities for this at the same time. And so first of all, standardization, I mentioned it before. Look at if there's a collaborative deployment model possible, including both financing and demonstration. And I will touch on the communication and promotion of SMR. So first of all, standardization. And this is much more than technology. Often standardization is focused on repeating the same plan design, and that's all. Well, standardization is more. It includes repeating the same supply chain, construction methods, the licensing models, the project structures, the training, the operating models. And the more that can be repeated, the lower and the more certain will be the cost. Another issue is the development of a collaborative deployment model. So potential customers should come together to develop the SMR market. Each customer's project depends on successful fleet deployment by the vendor. It was usual within the nuclear sector to go for nuclear plants one by one, or maybe 2 or 3 or maximum 4 at a site, but to go together with each their own project on different places, that's something new, and that could be maybe even essential for the development of the small modular reactors. Working together that creates the fleet required and reduces the risk of vendor failure. And you could assess your vendors together and then create the market pool to support the vendor developing a viable fleet model. And so, as you saw, there were 22 startups at the moment offering their various SMR designs. We can expect that only a few of them will survive and will actually be able to attract a group of customers. And also in this way, development costs are shared and standardized, and sufficient user base is there to maintain the technology going forward. So looking at the financing, and it immediately is connected to the project structure. You should develop a common project structure if you are with this group to manage risks and reduce the cost of capital. Fleet economics can increase confidence to in the program success that should be used, and good project structures will attract favorable financing. So financing is not a problem; it is an outcome. There's so much money in the world, so if you have a good project, you will be able to attract money, which was not usual in the nuclear sector until now, but it looks like there more opportunity also for nuclear plants to attract such money. So SMR demonstration, who will build the first? So the plus side, the positive side on this is that the government funding is possible. It has been, of course, demonstrated in the past. A recent one is this HDRPM in China, but in the past, it was already demonstrated. This German high temperature reactor, and exactly in a way. As I was just suggesting, the cost of the demonstration plant, to share that there were a number of small electric utilities that put themselves together. It were more than 10, and in this way financed the construction of this first pebble bed high temperature reactor. That was back in the 1960s. The downside, of course, of the demonstration plant, it is, of course, more expensive than the series model. This is because it's the first. It's also because you want to learn from the first. So there will be the measuring equipment, the maintenance equipment will be more expensive because you just want to know more about the functioning of this plant. Also, be careful on the communication of that. When reporting on the demonstration plant, the media will also try to report on cost. And if it's then oh, this plant is costing so and so much, and it becomes like synonym identical to the SMR design itself, then you're stuck with a kind of stigma which is hard to get rid of. So you have to really be careful on the communication of that. So talking about communication, has some tips, but I can only give that because there's not that much experience yet. What is always good is to promote your SMR for new markets. If you say, okay, it is all the other nuclear plants or other plants are providing electricity market, but now I'm going to provide this other market, there will be generally no problem. Of course, if you're and then it's even going to work better if you can promote your the fuel or the waste performance is significantly improving, much more fuel efficient, and per kilowatt hour, whether it will be heat or electricity, will have less waste, radioactive waste. But at the same time, be careful if you want to promote a better safety performance, because then you will engage with the regular nuclear industry, who will tell you, which was at least my experience, if you promote your plant as safer, then it also say at the same time that our plant is less safe or not safe enough. So to avoid that discussion, because you will need also part of the supply chain of the regular nuclear industry, you have to be really careful on the safety topic, communication. Of course, when talking about nuclear plants, any nuclear installation, be aware of the political and institutional aspects. It will always be as of national interest. It will attract internationally operating anti-nuclear organizations, NGOs. There's, of course, the institutional aspects, which are more safeguards related, and the media will be so much interested. And they will try to interview you, and sometimes it can turn out positive. They have a nice story, but you can also have a less nice story, and it's not entirely in your hand. So, and also it will, especially in the first phase of your company, when you're just trying with your new SMR, it will also cost a lot of time. So, be aware of that. So then finally, what are we then doing on the SMR business case at IAEA? So we're having a number of instruments that we can use, the so-called coordinated research project. So we have one on the economic appraisal of small modular reactor projects, which includes a number of business case studies. The idea of a CRP is that we are bringing together research organizations from member states, both developing and developed member states, to collaborate on research projects of common interest, in this case then these small modular reactors, and we have 49 participants from 32 member states, of which 13 member states never operated nuclear power plants before. Another instrument is through our Department of Technical Cooperation, a so-called regional meeting. So we had one for the region of Europe and West Asia, with 16 member states on the role of small modular reactors. The business case, well, basically this very same topic, and the purpose was to discuss the role of SMRs in future energy markets from the perspective of the owner of the SMR plant, who will have to justify his investments through a business case. So, and then finally, we are developing a publication on the business case for hydrogen production with existing nuclear plants, following various more technically oriented publications on nuclear hydrogen production, like the one shown. Yeah. So just to summarize a few takeaways, instead of concentrating much power generation on one side, SMRs could be distributed over the locations according to heat demand. The business case includes the market situation, competitive landscape, return on investments, and risks. The fleet approach would see SMR designs built in factories, promoting standardization through the building of subsequent identical units. And then I wish to thank you for your attention, and I'm ready to answer any questions from your side.
Thank you, Aliki van Heek from the International Atomic Energy Agency for that presentation. Super interesting, of course, and I have loads of questions to you, but before I jump into those, I just want to encourage you who are listening to also post your questions in the chat. We are going to, we're quite a few people in the virtual room, so we might not have time to address everything, but please go ahead and write your questions, and we'll do our best to address them, if not now, maybe also after the conference. And we will post the presentations from the conference, and also recording of the conference afterwards on our website, so you can all enjoy it again at a later time. But Aliki, I want to just start with a question that I think is sort of the obvious one that I've already got in the chat here also. When do you think that we'll see sort of commercial deployment of SMR?
Oh, your connection is lost. You're frozen. I hope you can hear me. So when? Well, actually, already two designs have been realized already. So that is the floating water-cooled nuclear plant and the high-temperature reactor. So these are already the first ones. Question is now, when will the rest come? And yeah, if you look at everybody's timeline, it usually speaks of.
See, yeah. At least I cannot hear you, Aliki.
Oh yay! Oh gee! Oh gee!
There you go. Yeah, now we got you again.
Yeah, yeah. You hear me again? Okay.
I can hear. So could you please repeat your answer there, please?
Yes, yes. I will repeat it. Already two SMR designs have been realized, have been built, and so they are operating already. That's what I showed. The water-cooled floating Russian nuclear plant and the Chinese high-temperature reactor. So these can be multiplied from now. For the Russian plant, we see at least efforts to do so. Not yet so much for the Chinese plant. And for all the others, if you look at their timelines in their information, it's usually talking about the second half of the 20s, 2030, somewhere like that. But that's still quite tentative. It's all depending, of course, on the funding and on everything coming together. So yeah, it's apart from these two, it's not really certain yet. There's some well, what you generally could say is that the group of water-cooled reactor designs, so that those are based on the traditional water reactors, they're closer, and there are several initiatives in the United States, one of them NuScale, that are well advanced with their licensing process and therefore close to starting the construction. Yeah, But the more advanced plants, like the fast reactors and the molten salt reactors, that is really at least a decade away.
So building on that and maybe zooming in a little bit on the European scene, just toying with the idea that everything sort of goes as well as it can in terms of all those barriers that we can go back to. When do you think we could sort of have a meaningful contribution in the European energy system from small and modular reactors as the ones that you've been talking about today? Is it also like a decade away? Is it 15 years, 20, or could we do it faster?
Well, we could do it faster, but it can also take more time because this is not a linear process. It's not like there's one built and then the next year it's two and then it's three but it's more like what I'm expecting, a more exponential process. If it is positive, then all of a sudden it will be very popular and there will be multiple orders. So then it will be multiplying quickly, but we don't know when that is. So nobody is saying anything about that. Only these like vague expressions of 2030 or 2035 or something like that. But that is really something that is we cannot answer that. and anything further than that. Also, there's these external factors that might help if there's this more awareness of climate change mitigation, and really the market or the competitive the competitor of fossil fuels is going to be taken away. Then there has something needs to be done, and then also there might become a push on governments and even regulatory institutions. Please hurry up because we are needing this. But this is something that is not yet. It is all that like, well, okay, we will see if when we can license this or whether there's a market. So so the sense of urgency is just not there yet.
So if I understand Dandy correctly here, that I guess it can simplify and characterize as SMR. There are kind of two dimensions to the attractiveness of SMRs. One, it's got to do with the cost and the potential cost reductions from standardized production methodologies and the scalability and modularity of these designs. And the second dimension, I suppose, that we can talk more about is the new applications that you can use these technologies for vis-a-vis large-scale reactors. So, first of all, is that a correct characterization, do you think, of the situation and the technologies?
Yes, that is quite correct. Yes.
So if we start then with the cost side, if again listening to you, it seems like the standardization of the production of these reactors is a key component there, and you listed a few parameters that sort of go into that bucket of under the category of standardization, licensing and so forth. Could you maybe elaborate a little bit? Which of those factors do you think is the most important to start addressing from a policy perspective first?
From policy perspective, what you mean what the government can do?
Exactly.
Yeah. Well, the government at least could create an so-called enabling environment. That means at least if there's a taxonomy that the technology is labeled in such a way that investments are possible. If maybe you heard about this green taxonomy that is now under discussion within the European Union, with the European Commission, that whether or not to label nuclear as green, of course, that will make a lot of difference for investors and therefore for the business case of the various SMRs, where all nuclear technologies basically. And then create also a level playing field. Of course, it's difficult to compete against renewable energy sources that have much better subsidy and tax environment than the nuclear plant has. Also, just like, in fact, they could just follow at the end what they did for the introduction of wind and solar sources. That they created this support measures like subsidies, like tax exemptions, like all kinds of planning where these sources could be placed. A similar thing could be done for the nuclear part as well. but and then it's of course a bit different. But
and do you think that there's a great gap here in terms of policy? Do we need a lot of policy action for these technologies to come to fruition, to realize their potential, or is this sort of more a matter of time and uptake on the demand side?
well, the way I see it is there is a certain, I say, government incentive needed to set the stage, and then the market has to take over. You cannot always rely on the government for putting more and more money for each of the units. But for the first one, a demonstration or a first group of units, there must be also some signal for the government, like from the government, like we support this, and also a kind of stability of support, because if you start with a nuclear plant, you have a lot of responsibility, obligation. You have to deal with radioactive waste and safeguards issues. That's a lot of investment up front. So you have to be certain that it's not only for a short period, but that you can do this for a longer period. So the government has to create an atmosphere that makes investors have trust, gain trust in that this is a viable investment, and that is automatically a longer term thing. And and in particular with this green labeling, that is a point of discussion right now. And their government could the other way around create showstoppers. If they're just creating label it non-green or even forbid. And in some countries, nuclear power is simply forbidden. Then your business case can be super the best. But if it's politically a no-go, then it's not possible. But
and do you think just picking up on that issue of the taxonomy, of course, is super relevant at this time. Do you think that is as a big opportunity, or on the flip side, of course, a big threat to SMR in particular, if that is or is not part of the green taxonomy?
No, it is an opportunity. And well, an opportunity, it sounds like nice to have, but this is a must-have.
So you mean that without being included in the taxonomy, it's basically going to make it much more difficult to develop these technologies?
Then it will be just much more difficult, because investors will have to look where to put their money, and so they will go for these so-called green investments first, and especially because the SMRs, most of them are not even demonstrated yet, so it's a risk for the investor as well. And so then such a government, this type of government support would help.
So then moving to the other dimension here about applications and how you can use smaller reactors for applications that perhaps not suitable for large reactors. Starting with heat, it sounded like one of the main barriers to using the heat from nuclear reactors is that they're not close enough to where you need the heat. So is that a true characterization? So if we could only move the reactors closer to, say, cities where you could use the heat for heating buildings, would that sort of be a major part of the solution?
Yeah, it is. Well, you should do it. Pull it the other way around. If the reactor is too far away, then it's a no-go. It's a showstopper. If you put it more closely, then this condition is fulfilled. But then still, it should still be offered at a reasonable price. For instance, a competitive price that the company of the community that is selling the district heat will agree with you providing the district heat. So that is one condition. If it's 3 times as expensive as the gas-fired boiler they had before, provided the gas is still allowed or available, then it's still a difficult story. And also there needs a certain level of public acceptance. If there's a lot of protests and the public does not accept, and there's a lot of successful engagement of anti-nuclear NGOs, then also, no matter what it costs, that's also a condition that needs to be fulfilled. So there's a number of traffic lights that have to be green, all of them.
And so, excuse me. You mentioned quite a few different use cases here and different business models. Where would you see it's been where we're closest to the market, if you wish, in terms of SMR applications for non-electricity applications. Where do you see the greatest potential being sort of commercialized in the near term, being in the next decade or maybe 15 years?
Yeah, that's why I showed the result of our PRIS database. I think you always need the basis of what is already existing. So there are a number of nuclear power plants that are already providing heat to industry and providing district heat. So I think these two markets are in the near future most important, because you can always then see, okay, look, that company already did this kind of business. It's now only a new reactor, which has these and these advantages. And then from these two, maybe the industrial one is even closer, because this is now, well, what you hear around below the surface. Already talks are going on. That technology developers are already talking with big industrial users. Would this be of interest for you? If it's of interest, what would be your requirements? And that they really have an interested ear. So that's already in preparation.
And do you think then that the business models and the way that who and how these operators or these reactors operate will change? So will we see industry players also operate their reactors, or will they be leased, or how will that work? How do you see that play out?
Yeah, that's still really not clear yet. Well, what I see at the moment is that there is these utilities that are really stuck kind of to their electricity sales, and some of them are also then moving out into onto heat sales. So still as an electric utility. If then there will be additional companies maybe buying the heat from the nuclear plant and then distributing it over the users, just like with electricity, that still has to be seen. We don't know yet. There are multiple possibilities. There are several probing activities to find out what is possible, but nothing. I cannot show you yet. Look, this or this company already is selling that.
So another point that is often brought up, of course, is the potential to reduce costs in the production just by the learning effect, just like we've seen in solar and wind, just the learning effect from when you deploy many units.
Yeah.
And you mentioned a number there for Westinghouse, around 30 to 50, I think you mentioned in your presentation. Is that the kind of is that in the ballpark where you see sort of the nth of a kind, that term that's often used when you look at these cost estimates and cost projections? Is that sort of the order of magnitude that we're looking at in terms of reaching those numbers? They're quite low. Yeah.
Yeah. That's what. So several tens that it makes sense to build a factory for building the components. That is what you have to think about, and that is I see as the main challenge for any SMR to come to fruition as a series produced SMR. That somehow you have to get some several decades of orders. Several tens of orders for units that it can justify the construction and commissioning of such a factory. And before that, there will be one by one, and then it remains expensive.
Yeah. So I guess I've, in other conferences like this and presentation, I've seen everything from sort of a more traditional style where you produce, like you say, maybe 1, 2, 5, 10 sort of units, to more shipyard style production where you envision sort of hundreds of reactors over a period of a number of years. And it sounds like you're somewhere in between there. We need to see sort of in the 10th and hopefully in the hundreds for these sort of significant cost reductions to come to bear. Is that right?
Yeah. That's right.
And just before we wrap up here, I just want to return to one issue that I saw in the chat also. Maybe you can elaborate. You mentioned that SMR, of course, is a sort of a bucket of technologies. And one question that often comes up is, what about the issue of spent fuel? Is SMR by definition better or worse in terms of how you can and should you handle the spent fuel?
Well, as I said, this SMR, it's a container term. There are many different designs, and some of them really have an improved fuel performance. And with this comes the waste performance, because if you use your fuel much more efficient, you will have also much less waste per kilowatt hour generated, or per kilojoule, as if you wish. But that's definitely not all. I mentioned there's these fast reactors, molten salt reactors. These SMR designs, they have these improved waste performance, so that you really can say, okay, and this is also then an opportunity when communicating. If you're communicating to a community that's kind of, I'm not sure, critical towards nuclear power traditionally, then you could say, okay, but this one is because you're always afraid of the nuclear waste, but this is much less waste. That is an opportunity in the communication, but it's not all of them. Many SMR designs are based on the regular water cooled designs, and their waste handling is just identical, which is also an opportunity, because then you can use the existing infrastructure of waste packaging, reduction, storage, and everything, licensing to storage. So that is then really the advantage of that part.
So if I get you right, then I guess in the short term, the greatest potential, and also some of the sort of economies of the existing infrastructure, is in favor of the traditional sort of design, but scaling it down, and then you'll have the advantage of the scaling down, but not really have any significant advantage in terms of reactive fuel. But then in the longer term, we can also see these designs moving into reactor designs that are also better in terms of the spent fuel. Is that correct?
Yes. Yeah.
Okay, great to straighten that out. So with that, I need to thank you a lot for your participation. Thanks a lot. It's been super interesting, and I'm sure that we're going to follow your work. And of course, the PRIS database, I know it's often used in our community, so we're very grateful for the IAEA just because of that. And thanks again for joining us today.
Okay, you're welcome, and thank you for the opportunity.